Good afternoon and welcome to NRCS's Conservation Outcomes webinar series. My name is Liz Marshall and I am the Outcomes Team Leader for NRCS's Outcomes team. The Outcomes team conducts this webinar series with three goals in mind: to highlight NRCS's conservation outcomes assessment efforts, to illustrate emerging opportunities for science-based outcomes assessments that can inform conservation delivery, and to demonstrate innovative conservation tools and data that can assist with conservation planning and with impact assessment. The webinars take place on the fourth Thursday of each month at 3 p.m. Eastern Time. We'll get started with the presentation in just a minute, but first I want to go over a couple logistics. The webinar is being recorded. All participants joining today's webinar are in listen-only mode, and all audio is being broadcast through your device's speakers. If you're having audio challenges, computer or mobile device headsets can help with your audio quality and volume. Also, please note there is a closed captioning link provided in the box on your screen entitled Today's Links. The captions open in a new browser window where you can follow along with the presenter's comments. We still want you to be able to participate in today's webinar, so please type any questions or comments into the Q&A box that you will shortly see on your screen. You can submit your questions throughout the presentation. However, the questions will be answered at the end of the presentation. Please also note the connection status bar indicator to the right of the Help button in the Adobe Connect menu. If your bars are all green, that generally means that your network connection is strong and you should be able to join in today's webinar. If you have a weak connection or you experience interruptions in bandwidth, however, that prevent you from participating, the recording will be accessible through the Conservation Webinar portal and the Conservation Outcomes Webinar Series webpage. The links to both of those sites are in the box on your screen labeled Today's Links. That box also contains several links to websites that will be discussed during today's webinar. Please note that the presenters for today's webinar have also provided a list of references for the citations mentioned in the webinar and a downloadable document listing the websites of interest. Those files and a PDF of today's slides are available to download from the box on your screen entitled Today's Handout. I'm now pleased to turn the microphone over to Matt Lohr, Chief of the Natural Resources Conservation Service, to introduce today's webinar. After Chief Lohr's introductory remarks, we will turn the reins over to Lisa Duranchik. Lisa is the Watershed Assessment Studies Component Leader for NRCS's Conservation Effects Assessment Project, and she will be moderating today's webinar. Thank you, and now over to you, Chief Lohr.
All right. Well, thank you, Liz, for that introduction and for kicking this off. And good afternoon, everyone. I just want to say thank you so much for joining in today, and I'm just really, really excited about these outcome teams webinars that we started a few months ago, and just excited to see the participation from stakeholders and folks that are interested to see the good work that our conservation efforts are doing, because we're really proud of the work we do. And so this gives us an opportunity to highlight various programs and really show that the programs work and conservation works. Now today, as Liz said, it's going to focus on CEAP, the watershed outcomes. And selfishly, I had the opportunity last fall up in beautiful Burlington, Vermont, to take part in one of these CEAP announcements. Senator Leahy was there, and the Undersecretary and myself, lots and lots of the Commissioner of Ag and the university president, and a lot of people all came together for this announcement because they were interested in seeing the effects of our programs and what the negative effects of runoff, phosphorus runoff are with Lake Champlain. But the beauty of it is, you know, we have programs in place, and through CEAP, we can actually measure the success of our programs. And that's really exciting to see, that to have an opportunity to back up the work that we do and the money that we spend. Of course, USDA spends about $6 billion each year on these types of conservation programs. So we want to make sure that we're getting the proper credit and seeing the benefits of that money. CEAP was founded back in 2003 as a joint partnership between NRCS and the Agricultural Research Service. But anytime you can combine agencies within USDA for programs, you're always going to have more success. And really, it was created as a way to really see what the outcomes of our investments are having, the effects that they're having. And today, you're all going to see that the conservation practices truly are working, reducing runoff and certainly improving soil quality, and mitigating the contaminants in these small watersheds across the country. So today's presentation is going to be summarizing basically 15 years of findings on several of these CEAP watershed studies around the country. But more importantly, when we have this data, it also teaches us and helps us improve the programs and make changes that can help these dollars to be even more effective as they're invested. So for our partners, our producers, for our agency, this is really a big deal. And just as a chief of NRCS, I'm excited to be able to give them the opportunity to show off the success and be able to toot their horn a little bit. So just want to say thank you for joining in, and thanks to Lisa and Daniel for helping to lead the presentation here today. Thank you.
Okay, thank you very much, Chief, for your comments and remarks. We appreciate you taking time out of your very busy schedule to join us for a little bit today. Thanks very much. So everyone, today we're going to hear a little bit in our Outcomes webinar series about measuring and understanding the effects of conservation in watersheds. And we're focusing on our Watershed Assessment Studies component of CEAP. Dr. Daniel Moriasi will be helping me present today's webinar. Daniel is with USDA's Agricultural Research Service. So as Chief mentioned, the Conservation Effects Assessment Project, or CEAP as we call it, began back in 2003 after the passage of the 2002 Farm Bill, which did include a significant increase in conservation funding. And so along with that increase in conservation funding, there were calls within and outside of the government both for better accountability. And so that's when USDA came together to plan this really unprecedented effort to try to document the effects of our conservation practices. So in the most recent Farm Bill passed in 2018, it was really reaffirmed and requested of USDA that we refocus our efforts and kind of double down on documenting and communicating the effects of our conservation practices. So lots of increased focus on outcomes. And to that end, I think our Undersecretary, Mr. Northey, recognizes that it's really imperative for USDA conservation programs to be able to be effective. And CEAP is an important part of our efforts to show the effectiveness of conservation practices. We have a long history in USDA of working towards this goal, dating back all the way to the establishment of some of these watersheds in the 1930s. And really the insights from CEAP, as the Chief noted, help us to refine our programs and our delivery to make these efforts more effective going forward. So our two goals for the Conservation Effects Assessment Project as a whole are to estimate the effects and benefits of conservation at regional and national scales, and this applies primarily to our national and regional assessments. And then also for our watershed assessment studies, we are also working to develop scientific understanding of conservation practice effects at watershed scales. So the whole CEAP project is complex, and it cuts across several different scales as well as resource concerns. And today we're going to be focusing on these watershed assessment studies, which are smaller scale studies. We have 23 active projects currently. In next month's webinar, you'll hear about our cropland component. Last month, if you tuned in, you might have heard about the wildlife component of CEAP. So for the agenda today, we really want to focus on sharing some background about the watershed assessment studies, as well as some examples of our findings. And we're going to present to you results from over 15 years of this watershed assessment, drawn from about 120 peer-reviewed papers. Of course, there's more than that in the literature, but to make this a manageable task for us, we tried to focus on just the papers that were coming out of CEAP projects, and those are the subset of ones that we included in this presentation today. So we'll give a little brief background about the watershed assessment studies, focus primarily on sharing with you examples of outcomes at these 3 scales, talk a little bit about how NRCS is using these insights and lessons learned, and then wrap up with a little bit on our future directions. So for the watershed assessment studies, we have 3 main goals, and these have been our goals since we initiated this component of CEAP back in 2003. This was one of the very first components of the CEAP project. And so our main focus is on quantifying measurable effects of conservation practices at the watershed scale. So these assessments do utilize monitoring approaches as well as modeling to help us understand conservation in the context of a watershed. And because they are very local in nature, findings from CEAP watersheds are used to inform local watershed conservation strategies. And here's a map showing our national network of CEAP watershed studies. Over time, we've had 51 projects. Presently, we have 23 active projects, and these are shown in bold on the screen there. The chief mentioned that last year we announced a new study that we initiated in the Lake Champlain Basin. We also had one recently in the Western Lake Erie Basin, in the Maumee River watershed, and 2 new ones just last year have begun in California in the Central Valley to help us learn more about the relationship between water quantity or availability and water quality. Partnerships are something that have always been very important to CEAP in general, and especially the watershed studies. We've had a number of USDA agencies as well as many universities, especially land-grant universities and extension, that have contributed to these evaluations and assessment studies over the years. And the producers are particularly important cooperators for us. These are smaller scale projects, so there is a lot of interaction with the private landowners, and their cooperation is critical to us being able to assess the effects and benefits of the conservation that's implemented on their private lands and in these watersheds. So we're grateful to them, but also to the conservation organizations and watershed groups that also partner in these projects. So we've had a number of products that we have released from these studies over the years, and you can find links to all of these on the CEAP website in the Today's Links section of the webinar. But also just to point out a few, our very first special issue came out in 2008. You will see some of those papers still referenced in today's talk. In 2012, we had an important synthesis study that was released, and that's that blue book in the middle there that highlighted the key lessons learned from a set of projects that we funded under CEAP in partnership with the National Institute of Food and Agriculture. And we'll refer a little bit to some of those findings today. And then more recently in 2018, we have several papers relating to edge of field monitoring and nutrient management in a special issue of the Journal of Soil and Water Conservation. And just earlier this year, there was another special section on the Soil Vulnerability Index and an evaluation that we have conducted in the CEAP watersheds on that index. You can find all of those online. Most of the papers are open access. But today we're going to be highlighting this special issue that just came out on May 12th, so very recent. And we'll talk about some of the findings from essentially 15 plus years of our assessments within watersheds. So I'll give you the bottom line up front, and hopefully you'll stay tuned in for all of our examples. But essentially what we were able to determine through all of this analysis in producing this special issue in our overview paper within that issue is that 13 of 21 ARS Agricultural Research Service CEAP watersheds have demonstrated measurable water quality improvements at sub-watershed or watershed scales for at least one constituent that's been monitored. And previously, in that blue book that I mentioned, that NIFA CEAP Watershed Synthesis Study, we found that 6 out of 13 watersheds were able to attribute water quality improvements to conservation practice implementation. So this is all really important and you know, helps us to understand that even though it's really difficult to detect changes in water quality, improvements in water quality over time at the scale of a watershed, because there are so many things within a watershed, so many different factors that affect the quality of that water, we were still able to determine that over half of these long-term watersheds that we've assessed, we had measurable water quality benefits that we were able to show from conservation implementation. So very important finding. As the chief said, conservation works. So I'm going to turn it over now to Dr. Daniel Moriasi, who's going to take us through the next section of the talk and highlight some examples for us. Daniel?
Thank you very much, Lisa. So I'll be talking about some of the examples in the next few minutes. Effects of conservation practices in CEAP watersheds are measured at different spatial scales, as Lisa mentioned, ranging from small scales such as edge of the field to large scales, including sub-watershed and watershed scales. As the spatial scale increases, it becomes more difficult to discern quantifiable effects of conservation practices due to increased complexity of multiple systems and the associated variability. So as part of the CEAP spatial issue overview paper, we compiled, as Lisa said, a list of, here to be specific, 119 CEAP studies and summarized reported impacts of conservation practices at 3 spatial scales. These summaries are published online as a resource presented in supplemental tables, which are organized in the format which is shown in this screenshot. These tables can be accessed through the link shown in this slide, which is also provided in the overview paper. One thing I want to point out is that this is not an exhaustive list of studies, as Lisa's already pointed out. Next, we present a few examples to highlight mainly measured effects of conservation practices at each of these spatial scales. So we begin with 3 examples at the edge of field spatial scale. So in Goodwater Creek Watershed, Missouri, a precision agricultural system, or PAS, was developed and applied to address water quality concerns. PAS comprises of no-till, cover crops, cropping systems defined by zones, and precision applied fertilizers and herbicides. So monitoring began sometime earlier at the beginning of the formation of CEAP, and the results indicated that the PAS reduced sediment losses by 87% and overall nitrogen losses by 40%. Although no-till alone on clay-pond soils increased herbicide and dissolved phosphorus losses, PAS mitigated against these negative effects and maintained crop yields compared to the conventional system. Next, in Ohio, an edge-of-field monitoring network consisting of 19 paired agricultural fields was set up to identify a suite of management practices such as the 4R principles of nutrient stewardship and drainage water management. These were intended to mitigate mitigate against phosphorus losses in the artificially drained fields. The results showed that overall network results, which indicated that implementation of all these conservation practices reduced phosphorus loss in tile drainage. For example, subsurface injection of fertilizer reduced dissolved reactive phosphorus in tile drainage by 66% compared to broadcast application, as can be seen here in this graph. Also, drainage water management reduced average annual tile drainage discharge by 23%, nitrogen losses by 21%, and dissolved phosphorus by 56%. Implementation of CRP to address water quality concerns in the Beasley Lake watershed began in 1995 and continued through 2006. Implementation of crop buffers also began in 2006. Crop buffers consist of both row crops and mixed vegetative buffers, also known as quail buffer habitat, and measurements for this study were taken between 2011 and 2017. The results indicated that that CRP reduced sediments by 95%, total nitrogen by 57%, and total phosphorus by 75% during the late winter to early spring. During the same period, crop buffers reduced sediments by 73%, total nitrogen by 35%, and total phosphorus by 32%. Next, we present two examples at the sub-watershed scale, starting with another study in the Beasley Lake watershed, where 3 sub-watersheds were selected to study the effects of drainage ditches and sediment retention ponds on water quality. Measurements were taken between 2011 and 2014. And the results indicated that on average, ditches reduced total suspended sediments by 72%, total phosphorus by 65%, and total nitrogen by 59%. Retention ponds, meanwhile, reduced total suspended sediments by 88%, total phosphorus by 62%, and total nitrogen by 62% as well. Results from an earlier study indicated that total suspended solids during the spring season improved over time following implementation of a suite of conservation practices that included vegetated buffer strip conservation tillage, CRP, and quail habitat buffer over the years. Water clarity at the lake also improved significantly during the spring season. Improvements persisted across season. In Arkansas, 2 paired sub-watersheds within the Little Ditches watershed were selected to study the effects of cover crops on water quality. Results indicated that cover crops reduced suspended sediment concentration by 39%, phosphates by 53%, and nitrogen by 86%. So finally, we present 4 examples at the watershed scale, with a study beginning with a study in Upper Snake Rock watershed in Idaho. Over the years, conservation practices such as conversion from furrow to sprinkler irrigation, construction of water quality ponds, and application of an ionic polyacrylamide in furrow irrigated fields have been implemented to address water quality concerns associated with sediment and phosphorus. Monitoring for inflow and outflow at the watershed began in 2005. And the results indicated that that implementation of those conservation practices have led to an average of 150 kilograms per hectare per year sediment deposition within the watershed since 2012, compared to 460 kilograms per hectare sediment loss to Snake River measured in 1971. Below here, we can show that the amount of total phosphorus entering the watershed with irrigation water continues to decrease as total phosphorus concentrations in the Snake River continue to decrease. Analysis of inflow and outflow water samples from 5 ponds monitored in 2008 showed that on average, water quality ponds reduced sediment concentrations by 57%, total phosphorus by 31%, and dissolved phosphorus by 7%. As a result of the public laws of 1944 and 1954, NRCS constructed over 11,000 flood retarding structures or reservoirs throughout the country with a design lifespan of 50 years. Over time, these reservoirs have lost storage capacity due to sedimentation, with rates dependent on location topography, soil types, land management, and climate variability. A bathymetric survey study within the upper Watershed Basin in Oklahoma measured reservoir sedimentation rates and correlated the rates with various variables. The results indicated that reservoir lifespans ranged from a minimum of 45 years to 118 years. 11 out of 12 reservoirs surveyed having showed that they had a lifespan that was greater than the 50 years, as can be seen from that table. These higher lifespans were attributed to multiple conservation practices implemented over the years through the NRCS programs. In addition, correlation results showed the ability to estimate storage capacity and projected lifespan for various reservoirs using climate, soils, and topographic variables. In another study in Choptank, scientists used winter cover crop enrollment data combined with calibrated SWOT model to estimate water quality impacts based on known distribution of crop cover species and planting dates in Tuckahoe Creek watershed. The results indicated that adoption of winter cover crops reduced nitrate leaching by 25% over the 10-year period, and by estimated 38% when 64% of fields were planted to winter cover crops. Also, satellite remote sensing detected a trend toward increased wintertime vegetation as cover crops implementation increased over time. And last but not least, scientists in Iowa used geographic information system mapping techniques and historical aerial photography records from 1930s to 2016 to quantify the amount and placement of several conservation practices in the South Fork Iowa River watershed. They also compared findings of each conservation practice with the findings determined by ACPF. The results indicated that erosion control practices were maintained for 2 to 3 decades on average. Also, results indicated that practices were implemented mainly at HAC-12 watersheds where concerns for soil erosion were greatest. And in general, practices implemented in the watershed matched areas identified by ACPF as inherently needing erosion control practices. However, additional conservation opportunities remain. Now, what is important to point out is that findings from this and other research studies depend on availability of good quality data. One of the major CEAP accomplishments is the development of the Sustaining the ARS Watershed Agricultural Research Data System, or STEWARDS database. STEWARDS is a publicly available database for CEAP watersheds that contain soil, water, climate, land management, and spatial data. In the last 5 to 6 years, data has been downloaded approximately 25 million times from the STEWARDS database, on their website to support modeling studies, water quality policies, and education in natural resources. And now, I just want to go over back to Lisa.
Thanks very much, Daniel. So we're going to switch gears a little bit now, and next we're going to talk a little bit about how NRCS is using the information from CEAP and translating this science into practice. And Liz, I think I've lost the slides. I'm not sure if that's affecting others as well.
Sorry, let me go back in and...
Okay, and I'm just going to go ahead and keep talking while you're working on that to tell folks about this. So in NRCS, we have a few key opportunities to apply the science from CEAP to the business of our agency. And CEAP findings and insights, feed into several different aspects of our work. And hopefully everyone is seeing the slides again. So one of the ways that we use this information in NRCS is in the technology that we have. This includes things like our conservation practice standards, innovative assessment techniques that we've developed under CEAP, and conservation tools that have been either developed or evaluated. And we'll give some more examples of each of these later. Management is another way that we can use this information, and that relates to even at the field and farm scale, decision-making by producers and adaptive management on their part, as well as adapting the management of our conservation programs and initiatives. So we've used our lessons learned from our CEAP syntheses to inform the design of our conservation practices, the delivery approaches, some of the criteria that we use to evaluate projects, and of course, in evaluating the outcomes of these conservation initiatives and programs. And lastly, all of those things, but especially the outcome piece, feeds into the reporting that we do as an agency on the outcomes of voluntary conservation. And then others, of course, can take all of that information and conduct analyses to inform things like the Farm Bill. So it's pretty easy to see, it should be then, how CEAP fits into our conservation planning process in NRCS. So this is a figure showing the 9-step conservation planning process that we have. And so, for example, in the phase 1, identifying resource concerns and conservation opportunities to address those is part of what we do in CEAP. So developing tools to help us evaluate alternatives in the phase 2 is another way that we are applying some of the work that's gone on under the CEAP Watershed Assessment Studies. And then, of course, in phase 3, evaluating the outcomes of a conservation plan is very key to what we're doing as part of the Watershed Assessment Studies of CEAP. So I mentioned that we use our findings and our work in CEAP to support our technology in NRCS and our science basis. And this is just a sampling of some of the conservation practice standards that we have evaluated under CEAP Watersheds. Some of these have even been developed in CEAP Watershed Assessment Studies. So for example, the blind inlet is a modification of a conservation practice standard that was actually developed in a CEAP watershed in Indiana after noticing through an assessment that there was a resource concern that was not being treated in that case. So the practice was developed and implemented and evaluated over now more than 10 years. that is shown to be very effective at reducing sediment as well as phosphorus loads, including dissolved phosphorus. And ultimately, this practice became a full conservation standard for NRCS under our Environmental Quality Incentives Program. Also, the saturated riparian buffer is another example that's been shown to be highly effective in some cases at reducing nitrate losses under some conditions, and that's being evaluated in a number of different CEAP Watershed Assessment Studies now, moving that practice standard out of Iowa and to other regions of the country where it's relevant. In terms of tools and indices, one of the indices that we have worked on is the Soil Vulnerability Index. This is an index that was developed by the cropland component of CEAP, a different part of CEAP, as well as our geospatial lab within our branch. But the watershed assessment studies came into play as part of an evaluation of the output of the Soil Vulnerability Index around the country. So we had 13 watersheds around the country that participated in this network project. And our finding was that it was useful as a broadly applicable index to categorize risk. And so this index, the Soil Vulnerability Index, is now part of the new conservation assessment and ranking tool. It's part of the vulnerability assessment framework in that tool, which is used now by NRCS to evaluate applications for conservation funding. And moving along with tools, another tool that we have worked on in the Watershed Assessment Studies component is the Agricultural Conservation Planning Framework tool, which is developed by USDA ARS in partnership with NRCS and several universities. The ACPF Planning Framework tool was also supported by NRCS's Conservation Innovation Grants Program. So this shows a screenshot of a story map that was created of application of the ACPF tool in the CEAP watershed in Iowa. In this case, that's South Fork of the Iowa River watershed that Daniel spoke about earlier. And it's a tool that can help us to evaluate which practices can be most effective in different areas of the watershed. So if you're interested, take a look at that URL. It's also captured in the links paper that we presented in today's handouts, if you want to go back and look at that more later. So I mentioned that we do apply these insights to our programs as well in NRCS. And this can look like, for example, establishment of priority watersheds and even smaller scale phosphorus priority watersheds under the Great Lakes Restoration Initiative. So NRCS has phosphorus priority watersheds at small scales where we have identified the need to work more proactively on phosphorus reduction. That's just one example. Also, in our National Water Quality Initiative, we now require watershed assessments in all of those NWQI projects. And this is based on our finding that watershed assessments are really useful in helping to guide effective conservation implementation. So many of our water quality initiatives are utilizing precision conservation approaches. We have a new project for NWQI and the Mississippi River Basin Initiative as well, looking to utilize precision conservation approaches. Sorry, I'm hearing a little bit of feedback on the phone line. Thank you. And then also, we are working as part of the guidance for these programs to identify critical source areas, including identifying the pollutants of concerns, and then focusing on appropriate practices to address those pollutants and those source areas. And that would involve a system of conservation practices to avoid, control, and trap the water quality constituents of concern. Lastly, locally driven conservation strategies are really important and fundamental to NRCS and our conservation delivery approaches. And our work under CEAP Watershed Assessments has shown that one-on-one technical assistance has been particularly effective, as well as leveraging local conservation leaders and farmer-to-farmer networks where they exist or trying to support those. And a lot of this has been adopted by our conservation programs in trying to support these types of conservation delivery approaches. And of course, hopefully it should be easy to see now that you've seen some of the outcomes we've documented, that these outcomes go to supporting our reporting as an agency on the outcomes of our conservation, but also the science that we've done to develop these assessment tools and effectiveness estimates for practices feed into estimation procedures that we utilize to evaluate our progress in terms of environmental benefits over time from our conservation implementation. So wrapping up now with a little bit about our future directions and where we hope to go. I think this exercise of producing our overview paper highlighted for us that we can still dig into this information a little bit more, and we hope to do a synthesis study to help us better understand the scales at which different practices have been, effects have been observed, maybe which effects for different conservation practices have we been able to measure and which ones haven't we, and what can we do better to enhance our ability to detect some of these effects going forward. So there are many things that influence our ability to detect water quality improvements from conservation, particularly at the scale of a watershed. And one of these factors is legacy sources. Legacy sources of nutrients or sediments in watersheds are very important because they can serve as a source of chronic pollution to surface waters or groundwater for decades, really. So these untreated sources can really effectively mask the effects of present-day conservation efforts that we're having. Even significant levels of conservation implementation currently can be masked in the water quality if we're not also working to address any legacy sources that exist in that watershed. And it may require different types of strategies to effectively address legacy sources versus contemporary sources, or to address these sources that occur within fields and in the soil itself versus if the legacy pool of nutrients or sediment is in a stream system itself. So this is something that we are beginning to work on more. We have been addressing it, but we just began a new project in the Western Lake Erie Basin with the Agricultural Research Service and 2 university partners to help us look at legacy sources more. And we're going to look at this at multiple scales, from a soil particle scale and soil column all the way through the field scale within a field, at the edge of the field, as well as in the stream network itself. So a very comprehensive assessment of legacy sources that we're undertaking. Lag time is another one of those factors that affects our ability to detect conservation effects at the scale of a watershed in particular. So, lag time is the time that it takes for the effects of conservation practices to be able to be seen as benefits or improvements in stream chemistry within the water quality itself in the stream network. So the time from when a parcel of water, say, infiltrates into the soil to when it exits to the surface water. And there are different factors that affect this lag time. It can be the scale of the watershed, natural hydrology. For example, karst hydrology can affect the time delivery of water, watersheds that have a lot of groundwater interaction, or even altered hydrology or managed hydrology, such as tile drainage or ditch drainage. So this is something we're beginning to look at in a new watershed lag time project in USDA. And we are utilizing a technique that was developed in one of our CEAP watersheds in the Chesapeake Bay to help us quantify this lag time in a number of different watersheds around the country. Of course, we're going to continue our efforts to work on effective practices to reduce nutrients and sediment in watersheds. And we are going to be looking at also soil health and water quality relationships. Soil health is something that's very important to producers. We have work to develop sensors that is also going on to help us better detect the effects of conservation. And we are working on innovative practices to help more effectively reduce nutrients and sediment losses on the landscape to better improve water quality. Extreme events is another factor that is very influential with regards to water quality in watersheds. These are events that are also affecting the resilience of agricultural systems, so this is something that we will be continuing to work on. And this is just a map from the National Oceanic and Atmospheric Administration showing a range of different extreme events that were occurring in our country just in 1 week in July about 2 years ago. Everything from extreme heat to drought, extreme precipitation, and flooding. So all of these things feed into affecting the viability and sustainability of agricultural operations and are very important to the environmental benefits that we have from our conservation practices as well. So along those lines, we're also beginning new work. As I mentioned, in California, we have ongoing projects in Arkansas and other places that have been working to address factors such as drought or water availability related resource concerns. So in order to do all of this, we hope to be able to revitalize our watershed network a little bit, whether that's increasing our ability to monitor subcatchments and detect those effects, identifying where practices would be most beneficial, looking at stacking of conservation practices and measuring the sequential reductions that you can get from implementing a system of conservation practices, something new that we've been working on. And we're also interested in questions with our synthesis about determining the optimum catchment size, for example, to assess practices, or the length of time that would be required to assess the effect of conservation practices. So I just want to close with note that in July, the Agricultural Research Service will be publishing a glossy publication that's going to feature 2-pagers on each of our CEAP Watershed Assessment Studies. And once this is available, you will be able to find this on the CEAP websites for ARS and NRCS. And thank you very much for your attention today. And most of all, thanks to all the scientists and our partners who have worked so hard to help us document effects of conservation and better understand these processes. We appreciate that work. Thank you.
Thank you very much, Lisa. It looks like we have a few minutes for some questions, and we do have several questions. So I will go through the question list and just throw out some. If I'm not able to reach a question that you have, please contact either of the presenters at the email address shown on your screen. So one question is, does the special issue report break out watershed improvement per specific conservation practice, for instance, graft waterways?
There are some papers within the special issue that focus on individual practices, and so you can take a look at that. And then as well, those supplemental tables that Daniel mentioned have listings of references that report effects for different practices at different scales.
Okay, there's a follow-up question related to grass waterways, which is, has the effectiveness of two-stage ditches been distinguished from conventional grassed waterways?
So as Lisa has pointed out, I think the best way is to find the specific studies. I think we put the references for those different studies, and I think if you can pull up the papers, and just one thing to point out is that those papers they're paid for, and so they are just actually available online, and you can just get the paper and you can get the rest of the details.
Okay. One person asked you to elaborate on CEAP grant funding opportunities for enhanced sediment or nutrient reductions in sub or large-scale watersheds.
Okay, I'll take that one. And we don't really have open grant opportunities for CEAP. Or if you're interested in applying a conservation practice, in a watershed, you should contact our local NRCS office where you live. And if you're interested more in opportunities to evaluate the effectiveness of it, you're welcome to contact me by email, and we can talk more about how that can be done either through CEAP or some of our other programs in NRCS, for example, our Edge of Field Water Quality Monitoring under EQIP, or even possibly under the Conservation Innovation Grant Program.
Okay, and one viewer asks, how can we find the delineation of the phosphorus priority watersheds?
Okay, that is located on the GLRI website. So if you search for the Great Lakes Restoration Initiative or glri.us, you should be able to find on that website a map that shows phosphorus priority watersheds for that initiative.
Okay, and this question was raised during your discussion of the legacy nutrients. How do you overcome stakeholder expectations to see nutrient reductions following the implementation of BMPs?
That's a really great question. And thank you for asking that. So I think, one of the things that hopefully is obvious after listening to our webinar today is that it's very challenging to detect the effects of conservation, especially at larger scales. And so to that end, I think it's been really important for us to try to integrate into as many of these projects as we can smaller scale monitoring at the edge of the field. That's the first opportunity really to see the effect of the conservation practice implemented in a new situation. So I recommend considering that maybe as part of a larger project, but that too is really difficult to do, and so hopefully just having information from studies like this that really show that it takes a very long time to be able to show the effects of conservation often will help in communicating that fact to producers. So it doesn't mean that they're not having an impact. It's just to have an impact at a larger scale does take time and significant effort, not only from the cooperator producer, but many others that would be operating in that watershed.
Yeah, just I wanted also to point out that the fact that we are not seeing any effects right now, we're investing just into the future, because if we actually didn't do that right now, the situation will be worse than what it is. So sometimes when we might not see what's happening right away, I think just being patient and just knowing that if you're dealing with the larger scales and problems that have existed over a long time, we need to be patient.
Okay, we're at the top of the hour, but I have time for one more question, which is, given how episodic the delivery is of nitrates and phosphorus, how many years of water quality data do you need to detect the impact of conservation practices in a watershed?
I think, Lisa, I can just say one of the things that we are hoping to do with a very thorough synthesis of measured effects and taking some of these studies from the measurement, and I think we might have a little bit some more insight after that kind of work is done, which Lisa talked about the future directions on what it is that we plan to do. So I think we'll get a better handle of that question, and sometimes it might be more complex than what it seems.
There have been some studies done to look at that. One is a report by the Northeast Midwest Institute, for example, in the Great Lakes region from a few years ago, and they used some statistics to look at data and try to analyze that question, and I think their finding was a minimum of a decade to be able to detect effects in a watershed. And then also our NIFA-CEAP synthesis, I think, offers some perspectives on that. It's very dependent upon having an appropriate monitoring design in a watershed, as well as, having sufficient levels of implementation. But there are all those other external factors that we talked about that also affect our ability to detect that.
Okay, thank you. On behalf of the Outcomes team, I'd like to thank Chief Lohr, Lisa, and Daniel for taking time out of their busy schedules to provide an excellent presentation on the observed outcomes from 15 years of CEAP Watershed Assessment Studies. Thanks also to everyone for attending today's webinar. We'll see you next month for the next installation in the Conservation Outcomes webinar series, which will be entitled Tillage Management and Structural Conservation Practices, a CEAP 2 report on changes in adoption rates. Thank you and have a good afternoon.